Hi everyone. So right now I'm going to speak about the basics of physics. Okay? So let's start with what is physics. My spelling abilities are not so high. So we can now see what is physics. I guess this is more right as a spelling. I wish. Physics is the study of nature. Very simple. You look to nature and try to make rules out of what you see by doing experiments. Okay? So this is very short answer. Okay? To do this, the scientific method is used. The scientific method consists of experiments that are done in sorry, wait a second, in the simplest way possible. You ought to eliminate variables. Okay? The less variables, the more probable the experiment is going to yield a good result. So, let's go a little bit further. This scientific method was created, let's say, was created by Galilei. Of course, something similar to it already existed, but it was kind of rare to see. Okay? So we say usually that Galileo Galilei invented this scientific method. Okay? Now let's go further. What did we think before? Well, this is a good question indeed. What did we think before? Before, wait just a second. We thought Aristoteles was right. So, Aristoteles theory. Okay. This was of course not scientific, okay? Let's write it. Not scientific. It was philosophic. Okay? You ought to remember this. This theory was not scientific, but philosophic. So, let's get down to business. What was this theory about? Okay. There are 4 elements. What are these elements? Okay? The first one is ground. Then you have water. You have air. Wait just a second. Okay. You have air and you have fire. Ground is the heaviest fire is the lightest. Okay? So they get lighter and lighter. Water is lighter than ground, air is lighter than water, and fire is lighter than air. Now, ground really wants to be down. Okay? This is what Aristotle thought. He thought the ground wants to be down. If you throw some sand that is similar to ground, it will go down. Okay? Water will go down, but more slowly. Air will remain there, and fire will go up. Okay? So this is what he thought. He also thought about the thing called impetus. Impetus. That means very weird things actually. So wait a second. It's very, very complex. Let's say that if you have it, you can move without respecting the above rules. Okay? So it's kind of a weird thing, and in fact they do not exist. So I am going to end this because I want to be clear that this is not true. This is only what was thought almost 2000 years ago, in the first second century after Christ. Okay? Beautiful. Now that we have studied some history, we can go forward. I spoke about scientific method. What is this all about? What is the scientific method? Well, very interesting question indeed. Let's write it. What is the scientific method? Is a way of asking the nature for explanation. Okay? What do I mean? It's a way of asking the nature for explanation. If you want to know how fast things fall, you can't invent it. You must make a thing fall. And you can do this by experimenting, by making experiments that must be objective. That means equal for everyone, and verifiable. So you can prove or disprove it. Okay? So these are two very important things of the experiment: objective, verifiable, and yeah, that's it. So the full process is, now this was just a very simple explanation. Let's speak about the full process, the full scientific method. Okay? So, thing number one. Decide exactly what you want to know about. Exactly, okay? There is no way of saying perhaps this, perhaps the other, perhaps two things. Exactly. Do you want to know the gravity? Study the gravity. Do you want to know the moving on a straight line? Go for it. Do you want to know the moving on a circle? Go for it. But you must know exactly what you want to know about. Then decide what to measure, okay? Of course, if you want to measure a moving, you must measure how many meters you move and the time it takes you to move. Wait a second, right? Now, give an hypothesis. Give hypothesis. I think this phenomenon is due to, is caused by, and you say something. Then experiment. And we already said that experiments must be objective and verifiable. And then eventually change the hypothesis and go back to number 4. Otherwise, if the hypothesis is correct, you're okay. Okay? You've discovered a law of physics. Now let's go forward. Of course, making these two objectives, these two things, is not so easy. So let's ask, how can I measure things? This is not easy at all. This is not easy. It may seem like an easy task, but it is very personal. Okay? So how can you? Luckily, right now you can use unit of measurement. Okay? International system. Okay? You will find 7 different basic units of measurements. Units of measurement. Okay? What are them? Well, there's the meter, there's the second, there's the kilo, and there are many others. Okay? So these are just the most known. There are others. Okay? These units of measurement are defined in a really precise fashion. They are not random. Okay? They are defined with a precise fashion. For example, what is a meter? A meter is the distance the light travels in 1 out of, I am copying this number because it is very big, 299 72792 458 of a second. So look, it is very huge. That's 2,909,792,458 of a second. So let's say very small number. Okay, so you can see the unit of measures are defined in a very precise way. Okay, very precise fashion. Now let's go forward. Okay, I will skip something, not very much. Okay, now we'll get down to business. Right? Are you ready? How can I deal with big numbers? What if I have this number? What if I have this number? Okay, so you're now seeing this number is very huge. How can we make calculus with it? What if we want to, don't know, raise it to the power of 2? What are we going to do? Let's say this is the power of operator. What are we going to do? We are going to hang ourselves. This is crazy, right? No, this is not. This solution big, huge. Wait just a second. It also works for tiny numbers. The solution is called scientific notation. Okay? Now let's count. 3, 6, 9, 10. 3, 6, 9, 10. 3, 6, 9, 10. 3, 6, 9, 10. So that's 31 if I don't make a mistake. So 43, right? No, 41. Okay. So this huge number now became much smaller. Look. And now if we want to raise this to the power of 2, we can do this even with a pocket calculator. Okay? It's much easier. Okay? So you have, the formal definition is scientific notation equals writing a number as, oh wait, I'm going to put it bigger, scientific notation. Okay, writing a number as a product of A multiplied by B, with A that is a number from 1 to 9 inclusive. let's say decimal number from 1 to 9 inclusive, and b is a power of 10. It's 10 to, wait a second, to the n. So a power of 10 if you like more words. So let's read it again. The scientific notation is writing a number as a product of a and b. With a, this is a decimal number from 1 to 9 inclusive, such as this number. This is an example, 6.388. And b is 10 to the power of n. And these, now n is 41. And then we can make other operations. We can put it to the power, we can sum other numbers, and so on and so forth. So we know how to deal with huge or tiny numbers. Let's go forward. We are humans. Humans do errors. How do we deal with them? Okay. How do we deal with errors? There are many ways of many ways of dealing with errors. Let me just think for a second. Many ways. I think we're going to skip this and I think this question will remain unanswered. Sorry. This requires quite a big answer, because in a scientific thing, errors are not well accepted. Okay, so we must fight back. We must identify them. We must, perhaps do the average. Let's say perhaps average, perhaps medium error, perhaps uncertainty of measurement, and so on and so forth. Okay, so you can see very general answer. I hope you enjoyed watching this video. We covered quite a lot of stuff, really. What is physics? What did we think before? What is a scientific method? How can I measure things? How can I deal with huge or tiny numbers? And a little bit how to deal with errors. Just a little bit. So, thank you very much for watching this video. I really hope you enjoyed. And I want to say bye, and we will see, and you will be able to hear something more, perhaps about physics, perhaps about other things, who knows, in the next video. Thank you very much for listening. Bye bye.